It is recording, yeah.
Okay. Okay, perfect. So I'll start. Thanks everyone for joining. This is the first Dev Roundtable where we just discuss some interesting ideas and things around the coding in Ethereum land. As we all know, it's gotten a lot better, and a lot of it's still bleeding edge, so you hurt yourself a lot often. So this is one of the things that we encountered at Ujo was we wanted to be able to test if a throw occurred. And the reason why we wanted to do this was we were registering some metadata, and if some of the metadata weren't properly formed, wait, no, it wasn't that. But anyway, so let's just use as an example, then the contract should throw. But now we need to actually test if there was some kind of malformed input in there, which would result in a throw. But the biggest thing here is that, as we all know, that in the Ethereum virtual machine, that doing a throw means it consumes all gas. It's a thing that was invented specifically because there wasn't a way to actually do exceptions in the Ethereum virtual machine as is. So the way they made an exception was to essentially just tell the EVM to consume all the gas and then exit. This is something specific to Solidity. You could actually do your own custom throw, which is essentially just doing a for loop or while loop until gas is consumed. It would result in the same thing. So for now, adding a throw produces an out of gas error, which sometimes causes confusions because sometimes you do get legitimate out of gas issues, but you don't know if it was actually planned or not. But that's what we have at the moment. But at the end of the day, you need to figure out if a throw happened or not. But the problem with this is that a throw would consume all gas in the transaction, which leaves you with no real answer about what happened. And this is especially important if you're using Solidity for testing, because you need to be able to discern what actually happened. And if you use Solidity for testing and not, say, JavaScript for testing the contracts, then the transaction will literally throw and break the test. So you can't test anything more. It will break all the test libraries if the test libraries are written in Solidity, which Truffle has added with Truffle 3. So the first thing we're going to do is just like, let's just create a contract, which is something. And
Simon, can you increase the zoom on your screen? There's a
sure.
couple people in chat have asked for that.
Oh, not that much. That's good.
Yeah, let's
okay. So the first thing we want to do is just a normal function that says do throw, and all it would do is just throw. And then let's create another function that says do no throw, which will just do nothing. It will just execute normally. So this would be just assume it's a normal contract, and you want to now test like this should happen, like the throw should happen, and you need to be able to catch it and check it, and then assert that the throw actually happened. Now, the problem usually with this is something related to Solidity, which is Solidity has two ways of calling contracts. One is you actually use the contract calls, which is you use the contract names themselves, or you use role calls, which is of the form like address.call. Putting the actual function and signature there and crafting their own message data. Now, Solidity made its default safe by saying that if you use a contract call to interact with another contract, it's going to automatically rethrow if it encounters an error in the subcalls. So if you say, if you just do something like, so let's just start with saying, okay, we want to test the something contract, and you want to do s.doThrow. What will happen here is all of this function would call this function, it would throw, and if it comes to here, Solidity would interpret this as a failure in the subcall and also rethrow at this level in the call stack, and then also throw. But if you do the address.call function where you make your message data here, I can actually do this. It would be bytes 4, SHA-3, do throw. not go right now. So this would, if you do it like this, this call would also throw and consume all the gas. But if you do it like this, all that would be returned is 0 or 1 in the stack. 0 is it succeeded, and no wait, 0 is false. It means wait, hang on.
Yeah, 0 is false.
Yeah, 0 is false, and then 1 is true, which means the call succeeded. So if you do a throw, it would just return 0, but anything else after this would still continue to execute. Well, technically it wouldn't because it consumed all the gas, but if you did do no throw, it would just continue regardless of what happened in the subcall.
Wait, so I have a question.
Yeah, sorry, yeah.
So on line 17, if that, so if you set it to do throw, and it would throw in that function.
Yeah.
So even though the throw doesn't like technically propagate up, it does consume all the gas.
It does consume all the gas.
Isn't that kind of just as good?
So there are scenarios here where if your subcall only does a throw, then it should be fine because it's consuming all the gas. But if it returns a failure on the stack for some other reason, then it would still continue executing, but you wouldn't know something failed. So you need, that's why,
gotcha.
and this is especially important in scenarios where you're sending Ether around, and that's why the DAO happened, because they used this format and they were checking things. You should check the result of sending Ether, but that's a related topic that could be covered later. But in this scenario, like you're specifying the gas being passed through, so it will only consume 20,000, use up the 20,000 gas, and then still continue, do whatever. So in this scenario, it would still continue even though it used up all the gas in the subcall.
Okay, gotcha. Thanks.
Yeah. So,
question.
Yeah.
So you said that the return value is it's 1 or 0 depending on if it threw. Is that related to the actual return value if there is one for a method?
No,
like
that's
0?
Yeah, that's a good question. It's not related to the actual return value. The return value in Solidity is Solidity specific thing. The EVM would do it. The call stacks themselves. So as far as I know, and I might be wrong here, but as far as I know, if you do a return, it's not the actual, like if you return, say, a bytes 32, you would not, if you do address like call like this, you would still only get a 0 or a 1. It only tells you if it succeeded or not. You don't get anything else back. Yeah. So if you do here and says returns bytes 32, you would not retrieve a bytes 32 here if you use the address of call syntax. But if you use the Solidity style syntax, you would get the bytes 32 back.
So if do not throw returns 0 in the function, so like a uint 0 or something, call in the line 17.
Yeah, I think this would still only tell you if it succeeded or not. It would not return the actual return value.
Okay.
Yeah. I'm about 90% sure of that. but because of the fact that things like bytes 32 aren't returning 0 or 1, and this only tells you if it succeeded or not, I assume it's not actually doing anything about return values. So return values are only useful if you use the Solidity style syntax and not the raw calls.
Can we test this?
Okay, let's do this.
I don't want to take this off the rails.
No, that's fine. Okay, let's return one which is supposed to say it fails. Do not throw it. So the first thing you want to do is to say, okay, well, do no throw, which is like default one, which is uint 256 default one, and then uint 256 So under the first one, it should return 1, but on the second one, it should return 0. If we get it right, as far as I understand. Let's see. Oh yeah, well, Solidity already tells you you can't do it like this, but let's try bool. Sorry. Okay. Just to make sure we have the right Linux JavaScript virtual machine, create. So, I wait, wrong one. The first one returns 1, and false is 0.
I'll be damned.
I keep forgetting this, Mike.
Yeah, false is 0. Yeah.
False is 0. Yeah. So it only recognizes the.
So if you did return 0, it would be log result 0 and false still.
This. Yeah.
Sweet.
Yeah.
I did not know that.
So, like the point of the raw calls is sort of extract the returning things away from the.
Simon, are you not calling the other function that do throw on the second call?
Yeah. So 0. Yeah. So it did the same. Well, the same thing. Yeah. I just did the wrong one. Yeah. Thanks for catching that. So yeah. So if you do the call style syntax, it will only return whether the call's exceeded or not, regardless of what happens in the subcall. So let's continue from here. Okay, so one of the issues now is that you need to somehow test whether this call is throwing or not, whether it's a legitimate throw or if it's purely went out of gas. So the way that you can do this is one way that I discerned is something called the throw proxy, which is, I'll explain why. Actually, I'm not 100% sure about something right now. Something just came up, which means I might actually create something way more complicated. But anyway, let's continue with this just train of thought, just to explain some of the interesting syntax that Solidity has. So the thing is, like, you don't necessarily, oh yeah, that's why. You don't necessarily always want to do the syntax like this, right? Which is having to craft the style like this. It's useful to use just a normal Solidity style syntax, which is like this, the contract call style. Instead of having to like manually craft the message data in a style like this. So when you realize that there's two ways to do calls, one is the Solidity style, one which it rethrows everything, and one which is the draw calls, which doesn't rethrow everything. You can use that to extract the rethrow away from what you want to do. So the way you can do this is to basically pass this through a proxy. Now proxies, proxy contracts in general, in a testing environment, has mostly been used, and Solidity testing environment has mostly been used to have the ability to use another actor to interact with something. Like saying, we need to test if someone that's not an owner is fiddling with the contract, then it should fail. right? But you can use the same style to actually interact with the contract, but keep the Solidity style as syntax. So the next part here is to describe actually like how the throw proxy works. I think just to get an understanding, or like just touch base, you do understand the problem where if you use Solidity style syntax, your tests will fail because the whole test is failing if you're using Solidity style syntax. And you don't necessarily want to do this style of writing your tests where you have to manually go write the things like this. Does that make sense? Okay. So the next part is to describe how the throw proxy actually works. So what we want to do is we want to essentially have a separate contract that only acts as the thing that catches the failed result and then returns the result back to the test contract. So instead of doing everything in the test contract, it's just a specific contract that handles that failure logic, the subcall, and then takes a legitimate Solidity call, does a subcall that fails, captures it, and returns it back to the test contract, and then interpreting from it. That was core purpose about the throw proxy. So ideally, you would just want to say, okay, well, we have a fallback function, and if you understand a fallback function, it's triggered when you don't specify the function that you're calling. So, or like if you don't specify the function you're calling, or if you specify a function that doesn't exist in the contract, then it's always going to call the fallback function if the fallback function exists. And this has been sort of an interesting design pattern that has been useful in various ways and not useful in other ways, but in this scenario, it was actually useful. So what you can do with this is you can, if you call the fallback function here in the throw proxy, you will be able to get back the message data that whoever was interacting with the contract wanted to do with it. So if you do sorry, log data. So if you now interact with the throw proxy, what you'll do is you'll just be able to retrieve the call, all the back the data in the message data that whatever the person wanted to interact with, it will just log it and then also store it. The first thing you want to think about is like, why am I storing this message data when you're calling this? One of the unfortunate, unfortunate, depends how you look at it, things about the fallback function is it can't return any values. You can't do returns on it. So all other functions allow you to return values, but the fallback function doesn't. So if we just wanted to use the throw proxy by saying, here's the test contract, here's the proxy, do the test call that's supposed to fail, come back to the throw proxy, give me the result back in one call, you would have been able to do that. But unfortunately, the fallback function, it doesn't allow you to go back to the test contract. So the first thing you need to do is just like, here's what I want to call, stop there, store the data, and take it from there. So what we want to do additionally is where this actual data is supposed to go to, like if you're interacting with something. And so we need to create a target for this proxy, like proxies forward requests. So the target is when it's created, we just specify and say there is one specific target for the specific proxy. And then what you want to have then is say, we want a function that's just called execute, which just executes the current message data in there and forwards it to the target. And this is where we put in the ability to retrieve that information back, because it can't happen. It can't all happen in the fallback function. What you do is you say target.call, and then you say whatever the current data is, just forward it, whatever you stored, and then return the result. So this call would then say, I return 0 or 1, depending on the thing succeeded or failed or not. But then it actually returns the Boolean result of this, which is did the subcall succeed or not, and gives it back to the test contract to interact with. Okay, so I think more of it will make sense if I actually just start continuing to demonstrate what it actually looks like. So what we want to do in a test is we want to create the throw proxy, just call it T, equals new throw proxy. And we specified that the target is our the contract we want to interact with, which is the something contract. So we specified that the target is something. And then from here on out, now this is probably the most interesting part of the syntax, which is not obvious. I don't think it's in the Solidity documentation. And I don't think it's used often at all, really. But what Solidity does for you automatically is when you do set the following, let's say do no throw, right? What Solidity is doing here, it has like this internal ABI, right? And it's actually crafting the message data itself and then doing a call to the something contract. So it's by saying s.do no throw, it's creating the 4-byte signature of the function, and then there's no parameters in here, so it's not adding that in, but it's essentially crafting it itself. But what the interesting thing here is it uses the ABI of the something contract, right? So it says s.do no throw, but I know what something is, so I'm creating the ABI and I'm creating the function call and I'm sending it onwards. But here's where the interesting thing comes in. In this scenario, we know that S is actually the something contract. That's it legitimately. Like it means then that when you do this call, it will actually trigger this function because this contract is actually receiving the call. But what's interesting, what you can do is you can do this syntax. This would be the same thing. This syntax is exactly the same. But what it's saying is take something as an API, put the address in there, and then craft the message data as if I'm interacting with the something contract, and then send the message data to that contract or that call to that contract. But the thing is, this address, this syntax doesn't care what this address is. It doesn't check if it is actually a something contract or not. Like it can be anything really. And so this is how the throw proxy works, is by saying send this actually to the proxy contract, not to the something contract first. So this syntax is what's probably one of the more interesting things about this, because this is completely legitimate. But what's going to happen here is it's not going to interact with the something contract. It's actually going to send the message data to the proxy, which would then execute the fallback function, which is store the message data. And if you now do the do no throw function, the message data would be stored as do no throw in hex. The whole packed message data, it will be stored as that. And so when the next one you say execute, it would then say the something contract that we wanted to actually initially interact with, do the call and put in this data, and we'll forward it, and then we'll execute that function. So you're taking this like hop through to issue that call. So that's the interesting part of the syntax, is you can essentially fool Solidity. Well, I'm saying fool, it's actually legitimate syntax, but and you're actually fooling it to do other things with the message data, which means you don't have to write it in this style to get that back. So let's see if we can test this. Let's take this out. Do no throw, just do nothing. Do throw with throw. And if you now do this won't actually produce the throw. It will just store the message data in the proxy, this call. So the next thing you need to do is to say, whatever message data was stored in the proxy, actually execute the call and say, what is the result? Give me back what happened in the result. And and then we log it results, and then see what the end result is. I'm not sure if everything's correct, but let's see. True. Yeah, that should be correct because you said do no throw. It returns true on the stack. And it logged the message data, which you can see is there. There is the function signature. And it executed the do no throw, and you got the result back. But now if you do throw, you'll see that it produced false. And now insert favorite testing library. We like truffle test for the assert. And then that's how you test if the call succeeded or not. One of the interesting things here you might wonder is why is this actually continuing to log the event if all the gas was supposed to be used up? And the interesting thing is that Solidity itself always leaves a little bit of gas left just to try and continue and finish the thing. It doesn't actually. Actually, I need to go figure out exactly how much that is.
I think it's like enough to send a ether.
Yeah.
Maybe in case you need to refund somebody or something.
Yeah. So it still has enough to log the result. So in most cases, what you would probably want to do is to say, well, execute the subcall, but we know it shouldn't cost more than, say, 200,000 gas to do so. Hang on. T.execute. Yeah. So it's like, well, whatever you're doing down there in the subcalls, the tests, whatever you're doing down there, we have no idea what you're doing, but you probably shouldn't be able to use more than this. So it means that you're left over with enough gas to continue just asserting, essentially. So just to run your assert and see if it succeeded or not. So that's the basic gist of like the throw proxy, to be able to use like more friendlier syntax like this. And then also being able to catch the throws when it happens. Is there any questions about this? Just this one more thing I want to go into. That's a caveat with this style of testing. So are there any questions here just based on this?
Could you clarify what you meant by Solidity saves enough gas to send a transaction? Like did I understand that correctly? Like, I think you said when, like, the reason that it doesn't actually run out of gas is because it's saving enough gas to send some ether.
As far as I understand it, and Connor, you can correct me, but this is what I also remember. I need to confirm this separately as well. Is you want to, when Solidity was initially designed, like now for the most part, the best practices are done in such a way that this shouldn't probably happen, but it was developed initially in the sense that if there is something malicious happening in the subcalls, you can still do one or two more things before like exiting. But because of the fact that you don't actually know what happened in the subcalls and it failed, you should probably not do anything. Like they might have, and that's why like most of the best practices have changed to say like if subcalls fail and you didn't expect it to fail, just stop immediately before continuing. But it was initially designed that if something fails, then you can do something else. An example that Connor gave is do something, but if there was a malicious actor using up all the gas, there shouldn't be ether in here. Send the ether back somewhere.
Yeah. I think there's enough for like, definitely enough for sending ether back, maybe for making a storage operation. But yeah, it's like if you send ether to a contract expecting it to do something and it can't, then it kind of seems normal to get your ether back. But yeah, I think it kind of varies by how you use it. But if you use the Solidity's default, like the bubble up of the throw, then it doesn't matter. The transaction will get reverted.
That's a good point. It's only a problem in when you do it in this style, right? Because we use raw calls. If you use the Solidity style calls, then it will just automatically rethrow. So that little bit of gas that's left is anyway just going to be used up and rethrown. It's sort of like you're stopping, just throw everything, just get it done with. So yeah, I hope that makes sense. What else? So the one caveat here that I encountered while writing these tests is that you have to consider scenarios where it's dependent on who is the caller. So if you had a contract that had something like, you know, an owner, let me just copy this actually. Yeah, so if you had a contract that had an owner and said, well, you can only call these functions if you are the owner of the contract, right? Saying as owner, then you would. I have another scenario where the contract would actually do another throw, but you don't know if it was this throw or not. So it could be this throw or this throw, right? So what could happen, and what happened when I was writing the test, is I was writing the test proxy and the things were throwing, but I realized I didn't actually transfer ownership over. And so what you need to do is let's say there's a normal, you know, owned contract that has the ability to change owners. Then what you should do is, or keep in mind, is what you should first then do is the test contract is creating this contract. So the test contract is now the owner here, right? But now the third proxy is going to interact with the test contract.
Can the throw proxy be like inherited, or you know what I mean? Can the fallback function be part of the same contract that is making the call? Does that make sense?
You mean the test inherited for the test, or the?
So the throw proxy is like a separate contract.
Yeah.
In between the test something and the something.
Mm-hmm.
Can the throw proxy functionality be inside of test something? Like, can the fallback function be inside of test something, and then?
I see what you mean.
Yeah.
Yeah, but it's an interesting point. Like, could you just say, you could specify in here, just like call it locally, save it, and execute it. Yeah, actually, that would be possible. Let me think about that.
Then you preserve the message sender, right?
Yeah, that's a very good point. Yeah, actually, that would be substantially better than having to have to do the ownership juggling.
Fallback functions can be tricky, so I don't know for sure how it would work, but it seems like it would.
Yeah, because you would then say you would have to do syntax like this, right? Sorry. Like, so this would create a call back to here, and then you could, if you then say function fallback, whatever, this would call this, do throw, and then store it here. So I think that would be possible. You need to test that. I like that.
The target would have to be known, though, right? Like, you'd have to know the pass in the destination somehow.
Yeah. Yeah, but this does for the most part, because what you just really want is the ability to let Solidity create the message data without actually doing the call yet. Right? You want to use this style of syntax, but don't actually call yet. Like, don't do this. Like, just store it first, and then whatever the message data that was created, now I'm going to use that message data with a roll call. So it would be possible to do it like that, and it's probably more elegant than doing it through, like passing it through another contract. Yeah, good points. Yeah, thank you. That would ease up the problems. That would actually improve things in another way as well, which is one of the other caveats with this. But anyway, so the ownership thing is a problem. I'm just going to go through here, which is the previous one that I wrote, which is you first have to change the owner to the proxy contract, then do the stuff that you want to do, and then you have to tell the proxy to change it back to the original owner afterwards. So this is the syntax here. It's important in this scenario with the style of testing to 100% make sure that the kind of throw you want to test, because there might be other throws that accidentally get triggered, like the modifiers, or you might actually legitimately run out of gas. So what you should do is to try and where is this one? Yeah, what you should do is to try and run this with a function that does not throw, just to see if the way you're juggling everything here works legitimately, and then introduce the function that does throw, just to doubly make sure like your logic of producing the test is not actually producing the throw, and not the throw that you actually want to test. So yeah, that's the core part of it. The other caveat, which is the thing that's uncertain to me about how you juggle it, and this is probably something with Solidity testing in general that's difficult to do, is just like handling Ether. If you're testing with Ether, that's something I spoke to Tim about like the way Truffle can generate Ether for the test contracts now. You're sending it through, especially in Solidity self-testing. But putting this functionality into the test itself, kind of like you said, reduces the issue of having to deal with Ether. Because if you have to send Ether here, and this thing needs to interact with the thing, then it's like it gets more complicated. So that does help that issue somewhat. If you want to test things like, I want to interact with this contract, but I'm not sending enough Ether and it's throwing. And the proxy produces just like more things to juggle, because you have to juggle the Ether sending around, Ether sending back, and things like that. Because in this scenario, if the thing fails, then it should technically then send the Ether back. But in this style, it should be easier to do so, where everything's in the test contract. Let's see, something else I wrote. Yeah, that's the main gist of it. I think just the takeaway, really, I think is one of the most important thing here is just that to realize that how Solidity calls the contract calls function, they automatically propagate throws, and then having the ability to use raw calls, which captures the result of the subcall, but then you can do things with it, which allows you to test for failure of subcalls. And then the second thing is just this syntax, which is not necessarily intuitive, which is the ability to wrap an address with another ABI than the one you would expect it to have. So those are the core things here that I wanted to show. Are there any questions, comments, feedback?
This is super cool. Thanks for sharing all of your knowledge, Simon.
Thanks, Mike.
Yeah, that was, I'm super happy about that. Who wants to go next week? Okay, well, we can figure it out on Slack and quick.
Hey, Akil, you should do like an ultralight beam demo or something. Sorry to put you on the spot, but
yeah, I will actually demo a I'm happy to demo a smaller portion of that, like kind of a sub-module that I think is really interesting called Immor. So maybe that's a good one for next week. It's actually pure JavaScript too, so it'll be a little break from Solidity.
Cool.
Awesome.
Awesome. Yeah. Thank you guys, and enjoy your weekends.
Yep.
Happy Friday.
Thanks so much, Simon.